I'm meeting with Marti Anderson, an ecological statistician from Massey University.
Ecology is the study of plants and animals in their environment, interacting with one another, and they do so in ways that are not random at all. And statistics is a discipline that helps us to distinguish something that's kind of random noise from things that are actually not random but have some kind of signal. Well, I'm going to be drawing something which is a tool that ecologists use to try to visualize quite complex ecological systems with lots of species in them all at once.
Ooh.
And this thing is called a Multidimensional Scaling Plot,
Wow.
or MDS. So suppose that you wanted to understand a system and you started by just thinking about two species. So here's species 1, here's species 2. Suppose these are fishes. You go to places along the New Zealand shoreline where fishing is allowed, say, and there are kind of small numbers of each of these species. Suppose then that you went to some areas where there was protection from fishing, and in these circumstances there were greater abundances of each of these species. So greater abundance of species 1 and of species 2 would put you up here somewhere. So that's quite easy to visualize if you have two species. And you can look at this plot and say, oh, look, the sites that have protection from fishing are somewhat more like each other than the sites that allow fishing to happen. Well, what happens if you have more species? What happens if you have 5 or 10 or 20 or 50 species? How are you going to visualize that? There are lots of ways of measuring this, but one way is to measure how many species are shared, or the proportion of species that are shared. So between site 1, site 2, site 3, site 4, say, 1 and 2 might share, say, 50% of their species. 1 and 3 might share 80% of their species, and so on. Well, once you have that information, this sort of thing is called a similarity matrix. From a matrix like this of similarities, you can construct a map in 2 dimensions that shows you something about how similar the sites are. I can take the first point, let's say it's site number 2, and put it on my map. This might be a site where there's fishing allowed. Then I can say, oh, there's another site where fishing is allowed, and it's quite similar to this one. Maybe they share 85% of their species or something. So I can put that on the map, and so on. And I can keep on adding points and adjusting their positions relative to one another so that the distances that they are on this map reflect their similarities. And that's called a multidimensional scaling plot. So if there was a strong effect of fishing, we would expect a pattern on the MDS plot that looks a little bit like what we were talking about before, where there were just 2 species to consider. But now, the information in each one of these points is based on a whole set of species simultaneously, and I've worked out, well, these sites are similar to each other, these sites are similar to each other, and they're actually quite different. So the Goat Island Marine Reserve is another one that people might be familiar with, and in ongoing research by the Department of Conservation, we like to monitor what's going on over time in these marine reserves. So what happens when the reserve goes in, and what happens over time to the fish communities, and how can we characterize that? So MDS plots help to visualize the statistical results that we get more formally.